All right, so we're going to kind of look at some different types of reactions. This is going to be a good review of how we start to write and kind of balance some of our chemical reactions. We're also going to be looking at a couple of new types of reactions that we should be looking at when we start to think about our changes taking place. I'm going to minimize myself here so I can write directly on the screen. It's just going to be a little bit easier, hopefully, and more visible for you guys. Bear with me as I'm working through some of the technology. Try to make this as best as possible for you guys to be able to navigate. Again, just as a reminder, if at any point you want to pause it, try it yourself first. I'm going to kind of be working along. I just want to make sure you've got all the resources as necessary as we start to work through. So cool, let's take a look at some of these and make sure we're feeling okay on some of the chemistry pieces. So our first kind of reaction type for us to talk about as we start to look at our different species is a metal plus an oxide. So this is going to be a synthesis reaction for us. If you have a metal plus an oxygen, if you kind of react in a metal plus an oxygen, sorry, I'll try not to speak too much. Metal plus an oxygen is always going to produce a metal oxide. So for our first example here, sorry, 1 second. Come on back. Well, come on, wrist guard. Sorry, 1 second. Technical difficulties. Nope, not what I wanted. Undo that. Come on. There we go, wrist guard. That's what we want. Sorry. Cool. So for our first example here, calcium plus an oxygen, we would have kind of our calcium atom. We're going to react that with some diatomic oxygen. Remember that oxygen is diatomic in nature. And this is a synthesis reaction. They just stick together. Calcium forms a 2+ ion. So we're going to have calcium 2+, oxygen 2-, so calcium oxide. To balance this, we would need 2 of those and 2 of those calcium atoms. We could go through and put state symbols in. Metals at room temperature is a solid, oxygen's a gas. They make an ionic solid, so it'd be solid, gas, solid for our state symbols as we're working through here. So metal plus an oxygen, metal oxide, smushing together. Cool. Our next type we could have is if we take that metal oxide and we throw it into the water. If we were to do this, if assuming that this metal oxide is soluble, we would then have a secondary reaction. We would form a base. We sometimes call this a base anhydride, a base former. So for this example, we have magnesium oxide plus our H2O. We're going to form a base. Well, which one's going to make we know base is a hydroxide. That's going to want to get with the positive cation, so it's going to want to get with the magnesium. So we're going to form magnesium hydroxide. Magnesium on the periodic table is a 2+ ion. Hydroxide is a 1-. Hopefully got those coming back. So we're going to need 2 of those. And then our leftover bits, I don't think we got any. We've got 1 magnesium, 2 oxygens, 1 from the original oxide and 1 from the water, 2 hydrogens, 2 hydrogens. And so we would go ahead and call that complete. So metal plus an oxygen, metal oxide. If we take that metal oxide, throw it into water, we form a base. If we switch over to the non-metal side, we just kind of flip the script a little bit, right? So we still, if we take a non-metal plus oxygen, we get a non-metal oxide. In this case, we'd have our sulfur plus our O2. It's going to form our non-metal oxide. In this case, would be SO2. These are not going to feel as clean for us based upon, because these are going to start to be covalently bonded. And so I'll be sure to be very, very clear as to what they would start to form for us. If we take that sulfur dioxide and throw it into water, instead of making a base, we flip it, we make an acid. In this case would be, again, a synthesis reaction. We form that H2SO3, which is a weak acid, would stay together if we were to write our net ionic. We'll review net ionic here in just a little bit. Cool. If we take a metal oxide and a non-metal oxide, we end up with the salts. Oftentimes these would be in solution. If they were in solution, it's actually an acid plus a base, which makes salt and water. These last two are very, very similar to one another. So for this one, we've got our barium oxide plus our carbon dioxide. In this case, again, we've got a synthesis reaction. We're going to end up forming our barium carbonate. Ooh, excuse me, sorry. Our barium carbonate, CO3, would be the salt that's formed here. Hopefully this is legible enough for us to be able to be working through. If not, let me know. I'll buy a new stylus. Gives me a reason to buy a nice new pen. Cool, last one. Acid plus base gives us salt and a water. Nitric acid would be our HNO3. We're going to react that with our sodium hydroxide, NaOH. When we do this, we're going to make our water. The water comes from, sorry, let me get my arrow in here. The active particle of an acid is that hydrogen. The active particle of the base is the hydroxide, HOH, we rewrite as our H2O, there's our water. And our leftover bits in this case would be our sodium and nitrate. This would be our sodium nitrate species. Sodium's a 1+, nitrate is a 1-. And here is our final balanced equation. Sorry, there was a little icon there. Cool. Hopefully that is legible. If not, hopefully the audio comes back and lets you see what's going on. Cool. Let's take a look at a couple more examples just to make sure we're doing okay. A couple more just types of reaction I wanted to talk through with you just to make sure we're feeling all right. Sorry, let me clear this so I can. Yep. Oh, sorry. Let me wipe. And cool. Cool. A couple more examples for us to look at and start to think about what we'd start to form. So acid and our water, acid or bases in water. If we're just adding them directly to water, we would just kind of say that they're going to dissociate for us. So for this one here, as we start to look at our example, we would have nitric acid, HNO3. Oh my goodness. Sorry about that. Let me zoom in a little bit there. Oh my goodness. Oh my goodness. Oh my goodness. Oh my goodness. Oh, come on. Oh, come on. Sorry, guys. As we look at our reaction here for our nitric acid, HNO3, we're going to go ahead and add it to our water, H2O. We would just say that this is going to dissociate. Our nitric acid is going to give off that hydrogen. We're going to form hydronium, H3O+, and leave our anion behind, our NO3 1- species. So we just split them up. We would do the same thing when we look at our strong bases. Let me get them all up here. It's going to be easier for us as we start to navigate here. For our bases, if we just took a base and threw it into water, as we throw that base into water, we're going to start to see the same type of reaction. So potassium hydroxide, that'd be KOH. We're going to add that to some water. And we would just split it up again. So we're going to end up making our K+ ion. And we're going to have some OH- ion. And then, we got some water still floating around. If we were doing our ionic, we would then go ahead and get rid of our waters. Really, we would just show this as a dissociation of our potassium hydroxide splitting apart. This last couple, I'm going to let you kind of work through those. Net ionic becomes a little bit different for these, but it's worth noting that you get the same thing for all of these. An acid plus a base always gives you water and a salt. So let's do the first one, just so we can review kind of that general archetype, but all of these are going to do the same thing. It's just when we get to that net ionic piece, how we would start to express those. And we haven't reviewed that yet. Don't worry about that quite yet. So if we look at this nitric acid, HNO3, reacting with our potassium hydroxide, our KOH. Active part of an acid is the H, active particle of the base is the OH, we make water. And a salt, in this case the salt would be that potassium nitrate. We could then go back and think about our solubility rules, predict whether they were aqueous or a precipitate. We're not quite to that point, but I just want to kind of give our general archetypes here. Cool, let's take a look. Oh, cool. So these are kind of the big ones I want to review for us as we start to think about our reaction types. Our next piece here is to look at some new reaction types that we haven't seen before and how we start to make some special gases, but we'll save those for another day.